So now we have defined the contact between the bodies, and after that we need to assign section properties and part definition. This is what we tell to LS Dyna about what kind of element each body is made of, how thick it is, and what material governs its behavior. But one thing I've discovered though is if you go to the tree, to the feature manager tree, you see that we have not yet defined the material. So we are going to define to the material along the way. So now let's understand the physics logic first, as we always do. The plate is thin. The plate is a thin, flat structure. It behaves like a shell. The thickness is much smaller than its lateral dimension, so the shell element is the correct abstraction. The ball, on the other hand, is a solid three-dimensional body. No thin wall assumption is valid here, so we use solid element that resolve the full volumetric stress state. This is not just a software choice. This is, choosing the wrong element type violate the underlying mathematical assumption and produces physically meaningless results. So we are going to start with the plate. And for us to assign the shell to the plate, we are going to, as usual, FEM, model and path, and keyword manager. There is another shortcut to enter the keyword manager, but for now, let's stick to our path. We are going to see it later. As you see here, the material has not been assigned yet. So we are going to all, we are going to select all, and we are going to section and shell. We double click on shell. Now we are going to add. After we've added, we are going to give it a name. We are going to call plate shell. Perfect. No, shell. Perfect. Now the section ID 1, the element form 2. We are first of all going to give it the thickness. The thickness is 5 millimeters, so we are going to get 0.05 here. Now for the element form, one thing you need to understand is if you click on the element form here, there are so many equations: equation 1, equation 2, equation 3, equation 4, equation 5. Here we are at the default equation 2. Now, to know more about this element form and to know the number of integration points that you're going to use for each element form, what you can do is you can go to the LS PrePost manual. And if you don't know where the LS PrePost manual is, you can just go to your LS Dyna installation. Just go to this. You go to LS PrePost. You right click, open to file location, and most of the time you will see help. And here you have the LS Dyna volume 1. This one, the one we are looking at is the volume 1. You are going to see the volume 2 and the volume 3. So when you are inside the volume 1, the LS Dyna volume 1, you go to the section part. In the section part, you go to the shell section part, and this is it. Here is where we are. You can see section shell. And now we have the definition. Here we are in equation 2, which is the Belichote. And from there you can read here and understand the different number of integration points that each section might need. So let's get back to our LS PrePost. Now inside LS PrePost, we know that we're going to use the default ES2 integration points. So we are good. We are going to accept and done. Perfect. Now we are going to assign the ball. In fact, we are going to assign the section for the ball. Let's go to solid. We know that ball is solid, so we are going to double click on the solid. We are going to add. It gives the section ID immediately, and it's our second section ID. We are going to the ball. We are going to click to give it a name, ball solid. After we are done giving it the name, we are going to look at the element form. Here I'll still use the element form 2, and from here you can see the different applications of the element form. So we are going to accept, and we are done. Now, one thing we need to do is that if you go to the part assignment, let's go to section. We pull down the section, we go to part assignment. We can go to the part assignment first, but what will happen is that when we finish assigning the part and we want to apply the material, it will give us a small warning sign that will say no material actually present. Will you want to assign or create a material? So I think it's better we first of all go and create the material, you see. So now, creating the material, I'll go to mat. There's the abbreviation for material in LS PrePost. So I'll go to material 24 because that's what we're going to use. And the piecewise linear plasticity is the most adapted for this kind of simulation. So I'm going to select the piecewise, double click on it, and I'm going to add it. And I'm going to call it plate plasticity material. Okay. Now, at the level of the mass density, we are going to use 7,850. At the level of the Young modulus, we are going to use 209 E9 megapascal. At the level of the Poisson's ratio, we are going to use 0.29. At the level of the yield stress, we are going to use 500 E6. At the level of the tangent modulus, we are going to use 10 exponent 9. So we are good. Now for the first effective plastic strain and second and all of that, we are going to see it when we will be doing maybe a more robust simulation, you see, or later on in the course. So I'm going to accept, and I'm done. Now we are going to assign the material for the ball, and for the ball we are going to use the elastic material. Let's go to 01. Not easy to find the material. Elastic, okay. Here's the elastic material. We open it, double click, and you see here we are going to add first, and we are going to give it a name, and the name will be, let's say, ball elastic. Perfect. Now we are going to the mass density, and we're going to give it 2,850. We are going to the Young's modulus, and you're going to give it 72 gigapascal, sorry. We are going to the Poisson ratio, and we're going to 0.3. That's all for what we're going to add. So we are going to accept, and we are done. Okay. Now for the material, we are good to go. Now you're just going to assign the part. Now we go to part, double click. Inside part, we are going to, inside the part, that's it. The title I already said. We take for the plate, the part ID is 1. Now we will assign the section ID. Now the section ID is plate shell. That's section ID, done. Now the material ID for the plate shell is the plate plasticity material, and we are done. And you can click on accept, done. Now you can go to the ball. With double click on ball, we have a by RG2, the section ID, ball solid, done. The material ID, We're going to the ball elastic, done. And now we accept. After we accepted, we can directly click on done. Now we are good. Now, what you need to understand is that the part keyword is the assembly point. It is what links your geometry, your element behavior. When I'm talking about the geometry, I'm talking about the mesh. When I'm talking about element behavior, I'm talking about the section. And your material law into one complete physical description. Without all these three assignments, the solver will either abort or produce garbage result. Don't always remember, garbage in, garbage out. If your solver exists immediately with a fatal error after initialization, the most common issue is a part with a missing section or material assignment. Always verify all three columns are filled for every part before running. Quick thing to note, if you want to understand the material assignment and all what it can say, like you want to read the documentation, it's quite easy. You still go to the LS manual, but instead of going to the manual 1, you're going to go to the manual 2, and here's the manual 2, the volume 2, and from here you're going to go to the content, you're going to go to material. So now let's say we want to see what was our material 24, the piecewise linear plasticity. Now from here you can read everything that concerns the piecewise linear plasticity. You can read everything, the variables, the description of that. So that's for the material. So now we have defined the part properties for both bodies. After that, we need to define the analysis output setting, and this controls the result in LS Dyna, and it actually arranges what LS Dyna will give or write to the disk, and we will cover this in the next lecture. So stay tuned and have a nice day.